So welcome back to the next class of chemical dynamics. So in the last class we have discussed about the acid base catalysis, and we have discussed one of the mechanism of acid catalysis reaction. So now in this class we will start with the second mechanism of acid catalyzed reaction. So here in the first step, what is happened? Obviously the substrate will be getting protonated and the rate constant for the reaction will be K1, and a protonated substrate complex will be forming along with the release of a base H. Whenever HA will be dissociates, it will dissociate to proton and base, conjugate base. This is the conjugate base of this acid. That means these are conjugate acid base pair. So in the next step, what will happen? Due to the addition of proton to the substrate, this substrate obviously it will undergo a change and a product will be formed, and after the release of proton, and that proton will be in the earlier first mechanism which we have discussed in the first mechanism. We have discussed that the proton is received by the water molecule, but in this case the proton will be received by the base, and the rate constant of the reaction is K2. That means HA is produced along with the substrate get converted to product molecule, and this substrate proton complex can again be further dissociated into substrate and obviously the proton source. Therefore the rate constant would be K minus 1. So this reaction is generally fast in nature, this reaction is generally slow in nature. So obviously the rate of the reaction will be equal to the RDS, that means the rate determining step, or that will be the slow step of the reaction, and in rate constant involving K2, and it will be the proportional to concentration of SH plus and concentration of A minus. Let us consider this to be equation number 1. But the thing is that the concentration of SH plus cannot be monitored with due time. Why? Because this is a transient species, and then this is higher energetic species whose concentration cannot be calculated or monitored with due time. Therefore we will apply steady state approximation to SH plus complex, subtract proton complex, and according to SSA, the change in concentration of substrate proton complex with due time is constant. That is, the change in concentration with time is equal to 0. That is, the rate of formation of SH plus is equal to rate of deformation of SH plus. So talking about rate of formation, in which reaction the SH plus is forming? In the first reaction only, and for that the reactants involved are rate constant K1 and substrate concentration and concentration of HA. And in which reaction the SHA plus is deforming? This is in case this, and the reactants are SH plus and A minus, and the rate constant involved is K minus 1 SH plus concentration multiplied by concentration of A minus. And again in this reaction also the SH plus is deforming, therefore the rate constant is K2 proportional to the concentration of SH plus and A minus. Okay, so K1 into concentration of substrate into concentration of HA is equal to taking SH plus concentration term to be a common term, and it will be K minus 1 plus K2. In the bracket I can take A minus to be a common also. Therefore SH plus concentration will be equal to K1 into substrate concentration into HA concentration of HA divided by K minus 1 plus K2 into concentration of A minus. So this is the second equation, and this equation actually tells about what is the concentration of SH plus at a particular time. Okay, so putting the value of equation 2 in equation 1, we can get the rate is equal to K2 into K1 S plus into HA concentration into A minus concentration divided by K minus 1 plus K2 to A minus 1 concentration. Cancelling this A minus 1 concentration in numerator and denominator, we can get back to the equation K1 K2 into concentration of substrate into concentration of HA divided by K minus 1 and K2, and this is the rate expression involving the A minus edge as a proton receiver in the final step. A minus is the proton receiver in the final step. Okay, so in the last class, the special cases which we have derived, that same special cases can be derived in this equation also. So likewise manner you can do. Okay, now, and this is all about acid catalysis reaction. But in the similar case, in the first mechanism, what we have taken acid. So in case of acid, if we will take base, then obviously there will be a substrate OH minus ion complex will be forming, and the second step there will be removal of the OH minus ion. There will be some OH minus receiver will be there. That means one will be acting as a base, another one acting as a conjugate acid pair. So there will be also a conjugate base and acid pair will be there if we will talk about the base catalyzed reaction. And similar type of expression can be found out by the same method which we have discussed in the last class and today class. So this is all about your acid base catalysis reactions. But now the thing is that the the rate of the reaction can be proportional to the concentration of H plus. Then it is said to be a specific acid catalyst reaction. It can be proportional to the conjugate acid. If conjugate acid, then it will said to be as general acid catalysis reaction. If the rate of the reaction is proportional to the A minus, it will be a base catalyzed reaction. If it is proportional conjugate base, it is a conjugate base A minus, therefore the rate will be a general base catalysis reaction. If it is proportional to OH minus specifically, then the reaction will said to be a specific base catalysis reaction. Therefore, if the rate, depending upon the situation, depending upon the nature of the reaction, the rate will be depending upon the H plus ion concentration, A minus, OH minus. That means the rate constant will obviously be depend upon the concentration of this species. So in general, we can write the rate constant is sum of the rate constant K naught plus Kh plus, when the rate constant is specifically depending upon H plus, it can also, the rate of the reaction can depends upon the hydroxide ion concentration, and the rate of the reaction can depends upon the conjugate acid, general acid catalysis reaction, and it can also depends upon the conjugate base, that is called as the conjugate the general base catalysis reaction. So the overall rate constant can be given as a sum total of all the rate constant, and where K node is nothing but the rate constant of uncatalyzed reaction. So for this class, this much only. Thank you so much. We will meet in the next class.